Hello everyone, this is the notes video for Unit 13.1, which is just dealing with surface area of pyramids and cones. You can see that learning target right there. I can find surface area of pyramids and cones, and you can go ahead and pause the video now and write that down. Alright, let's go ahead and look at our first formula, which is surface area for pyramids. And you see that formula PL over 2 plus B, referring to the surface area of a pyramid. You should be used to capital P referring to the perimeter of the base, and capital B referring to the area of the base. The one variable that you may not be used to is that L right there. That cursive L stands for something called slant height, which is a new term referring to the side right here that is a dotted line and labeled as 8. So I'm going to go ahead and highlight that right there and highlight that 8, and then I'm going to go ahead and make that L, which stands for lateral height. Alright, so as you can see, that is not referring to this edge right here. Instead, it is, you can think of this as the height of this triangle. Alright, so the height of this triangle is 8. So from there, we can go ahead and just find our capital P and capital B for this first example. This is a square, so for the perimeter of a square, we can go ahead and just take that side length and multiply it by 4. So that's going to be 7 times 4, which is 28. And then as for that capital B, the area of the base, that is going to be, you can think of side squared or base times height. So that's going to be 7 squared, which is 49. We now have all three of our variables, which we can then just plug into the formula. So surface area is equal to the perimeter, which is 28, times the lateral height, which is 8. Multiply those, divide by 2. Once you do all that, you can then add 49. So putting this into our calculator, we can do 28 times 8 divided by 2. I like to hit enter at that point and then just get that. That's 112, then plus 49 gets you 161 as your total surface area for this. All right. So we have that. All right. Hello, everyone. Let's go ahead and take a look at example 1, where we have our base of our pyramid is an equilateral triangle. So we can see that all three of these are 10 meters. And then we have this height of the equilateral triangle that we do not know. Let's go ahead and label that as X. We will try to find that. And for now, we can go ahead and look at the perimeter, which we have everything that we need to find since we know that all three sides are 10 meters. So we can go ahead and say that the perimeter is 10 plus 10 plus 10, which is 30. So we can go ahead and say that the perimeter is 30, and then we can look at the slant height, L, and that has already been labeled as 9.5. We see that right there. We can go ahead and plug that blank in as well. And then lastly, we need the area of the base, capital B. So for a triangle, that is base times height divided by 2. I'll go ahead and write that formula, but we know that the base and the height have to be at right angles. So we have this base right here, and then we have a right angle with this height, but we don't know the height. We labeled it X. So in order to find that X, we are going to use the Pythagorean theorem, because we know that we have a little right triangle right here. We can see that this 10 is the hypotenuse, and then we can cut this 10 in half, say that this length is 5. So using the Pythagorean theorem, we can say that 5 squared plus x squared is equal to 10 squared. So that's going to be 25 plus x squared is equal to 100. And then subtract 25 from each side. X squared is 75. And then if we take the square root of both sides, then x is equal to 5 square root of 3. All right, so by plugging that into your calculator, your simplified radical will be 5 square root of 3. So we can go ahead and say that right here. And then we will plug that into our area of the triangle formula over here. So, let's see. The base is 10. So if we look at this equilateral triangle, the entire base is 10. So we can do 10 times 5 root 3 divided by 2. And we know that 10 divided by 2 is 5. 5 times 5 is 25. So that will give us 25 times the square root of 3. All right, so that is our area for our base. And then you can just look up to the top of your page and recall the formula for the total surface area of a pyramid. Go ahead and rewrite that. P times L over 2 plus B. And then we just plug in the 3 pieces of information that we have already written down. So P is 30, L is 9.5, and then B is 25 square root of 3. And for this, we can go ahead and just put all of this in our calculator and round to the nearest tenth. So I'm going to do that myself. So it's 30 times 9.5 divided by 2, and then you can add 25 square root of 3. Just a reminder that the square root is control and then the square button right here. And then once you do that and round to the nearest tenth, you should get a final answer. 185.8. 185.8. And that's about all there is to it, to that problem. Now let's go ahead and look at example 2. This one is not as simple as some of the other ones because the base is not regular. It is a rectangle. So this 12, you can see, is longer than this 10. And that means that we are going to have to do things a little differently. Namely, a rectangular pyramid does not have one slant height. It has 2. So it has this slant height, and then there's the slant height coming to the 12 side, and those are not the same thing. So we are going to need to solve for both of them and then average them to get the slant height that we need for our formula. But to start off with, we can go ahead and calculate the perimeter and the area of the base because this is just a rectangle and we know how to calculate those. So to start with the perimeter, we know that this 10 is also over here and this 12 is also over here. So we'll just add all of those. 10 plus 12 plus 10 plus 12. And that is going to give us 44. We can go ahead and plug that in to this blank over here. And let's go ahead and get the area of the base finished as well. For a rectangle, that is going to be base times height. So that's going to be 12 times 10, which is 120. All right, now we need to find our 2 different slant heights. This is going to require some different techniques that we've learned about triangles. So, first of all, this slant height right here, let's go ahead and label that as x because that's what we need to know. We need to know our first slant height. And we know that this angle right here is 60 degrees, and we have this arrow that indicates that this height is 10.4. So this 10.4 you can see is opposite of that 60, and then our slant height is the hypotenuse of that right triangle created right there. So we are going to use or sine in order to solve this. So sine of 60 is equal to the opposite, 10.4, over the hypotenuse, which is x. Now, whenever the variable is in the denominator, we are going to divide. So x is equal to 10.4 divided by sine of 60. Let's go ahead and put that in our calculators and see what we get. So 10.4 divided by sine of 60. And this is incredibly close to 12, so we will just round that to 12. So I'm going to call this L1, meaning that this is our first slant height. Right? Now let's go ahead and take a look at our other slant height. So this is a slant height that goes to the 10 side. Now we're going to need another slant height that goes to the 12 side. And I'm creating that right there. And even though it doesn't look like it, this is another right angle. So we have another right triangle, if you can kind of visualize that. This slant height is essentially coming towards us. And since this whole side is 10, and we are essentially cutting it in half for this right triangle, let's go ahead and label this as 5. So we know this is 5, and we know that this height is 10.4. We are now going to use the Pythagorean theorem to solve for our other slant height. I'll go ahead and call it y. So let's go ahead and write out 5 squared plus 10.4 squared is equal to y squared. And let's do 5 squared plus 10.4 squared in our calculator, and we get 133.16 equals y squared. Then we can square root both sides, and putting in the square root of 133.16 will yield approximately 11.5. And like I said, we are going to call this L2 to indicate the second slant height. So now we have our two slant heights. So whenever you have a rectangle, you need to solve for two slant heights, and then we are going to use one final formula. I'm going to write it up here. Our regular L that we need is going to be L1 plus L2 divided by 2. So this, let me move this paper over to make sure that we can all see it. This is going to be 12 plus 11.5 divided by 2. I'm going to go ahead and kind of separate these two problems. But then we can go ahead and plug that into our calculator. And upon doing that, we should see that our overall slant height is 11.75. So if we average the two slant heights and then plug it into the formula, it will work the same as the other problems. So I'm going to go ahead and say that our overall slant height is 11.75. I'm not going to round to the nearest tenth here because 11.75 is a relatively stable number, and it'll work better to give us the answer that we want for our final answer. I'm going to go ahead and copy the formula for surface area over here, PL divided by 2 plus B. And then let's go ahead and plug in 44 times 11.75 divided by 2 plus 120. And after doing all of that, our final answer is 378.5. That's all there is to it. So keep in mind that for rectangles, you will have two different slant heights. Now we can go ahead and move on to cones, which are pretty similar, but we are now introducing a circular base. So you will recognize some letters from various parts. You can see that the radius is on there, so let's go ahead and label that radius. We should be used to radii. And then lateral height is still on there. So instead of it being the height of a triangle, as it is with pyramids for lateral height, it's simply just the height from that tip to part of that circular base. So it kind of carries similar meaning. And we can go ahead and label these in words. We can say that this is radius. And, oh, I think that's actually pointing to this. So we can go ahead and label that as our lateral height. So that right there, that L is lateral height. And R stands for radius. All right, so our formula is pi r squared plus pi r L. So we can then take those two pieces of information and use them to find our surface area of a cone. So right here with example 3, we have this whole dotted line is 9, so we can cut that in half to find our radius. So our radius would be 4.5. And go ahead and move this down, and we can see that r is 4.5. All right, and then the lateral height from the tip to the part of the circle we do not have. We will have to use Pythagorean theorem to find it. So 10 squared plus 4.5 squared equals c squared. And we can go ahead and plug that left side into the calculator. 10 squared plus 4.5 squared, and you get 120.25. And that is equal to c squared. And then take the square root of both sides. And the square root of 120.25 is 10.96. We'll go ahead and round that to the nearest tenth. We'll go ahead and round that to 11 because that is pretty close to what it is. And that'll be our lateral height. So you can say that our lateral height is 11. And then we have the two pieces of information from our formula. So now we'll say that the surface area is pi RL, so times 4.5 times 11, and then plus pi r squared. So that's pi times 4.5 squared. We'll go ahead and show this two ways. First, we'll multiply out everything except for pi. So 4.5 times 11 is 49.5. So we have 49.5 pi plus 4.5 squared is 20.25. So you can go ahead and combine those numbers, and we can see that our surface area is 69.75 pi. We'll go ahead and put that right here. And then if we put this in our calculator, we can get a second version of our answer, 219.1. So you can either write it in terms of pi, or you can put this and round it to the nearest tenth. You may see either of these versions on your test, so be aware of that. All right, let's go over and try to do example 4. And this one, we have our lateral height as 12. We can go ahead and put that down. So our lateral height is 12. And then for our radius, we will have to use trig. Let's go ahead and use this triangle that they give us to identify that this is our hypotenuse. And then we are looking for our radius, which is the opposite of our 30. So this means that we are going to be using sine. So let's go ahead and say that sine of 30 is equal to x over 12. And then we will have to multiply 12 times sine of 30 to get x. All right. So 12 times sine of 30 is 6. So that works out pretty well. So x is 6, which is in fact our radius. All right. And then our next step is to just plug into the surface area formula. Pi times the radius times the lateral height plus pi times the radius squared. I'll go ahead and do a little bit of marking where this problem is as opposed to this problem. So 6 times 12 is 72. 6 squared is 36. And then we can add those together and get 108. And then if you plug 108 pi into your calculator, you can also say that it's 339.3. So be used to knowing how to write that in both ways. All right, there is one more problem for the advanced notes, but if you are on the regular notes, this is likely all you have. So if you are not in an advanced class, you can go ahead and stop watching this video now, but I'll go ahead and go over the last problem that is only on the advanced ones. All right, so this problem is talking about a tower with a total height of 20. You can see that the height of the rectangular, or actually the square prism, is 20, so therefore we are left with a height of 4 for the pyramid part of this composite figure. So we can go ahead and put this right in there. We can say that this height is 4. All right, so that height is 4, and then it says that the square base, the base is a square with an area of 16. Well, we know that if the area is 16, then that means that each side length is going to be 4. So we can say that this is 4 and this is 4. And then it asks for the total area of the tower. Well, in order to figure this out, we are going to need not the total area of this pyramid, because this total area includes this base, and we do not want to include that base. So instead, we are going to be excluding this base, so we'll be excluding this capital B, and instead we'll only be doing PL over 2. So let's go ahead and start writing that down. PL over 2, that is going to take care of these 4 triangles at the top. And then we are also going to have that square base, which we already know is 16. So we'll go ahead and add that square base of 16. And then we need to add these 4 rectangles. All right. So those rectangles, we can use the formula base times height, and then we'll just multiply it by 4. All right, plus base times height, and then times 4, because that's the formula for 4 of these rectangles. All right, now we just have to figure out a few different things. The perimeter is the perimeter for this square pyramid. Well, we know that this is 4, so that's 4. So each of these is 4. And if you multiply 4 times 4, you get 16. So we can go ahead and say that capital P is 16. And then for lateral height, we will need to use a little bit of Pythagorean theorem. So let's go ahead and we can redraw this triangle a little bigger. We know that this height is 4 because the total height is 24, and we did 24 minus 20. Then as for this, just like with a previous problem, this base is only going to be half of the total side, so that's going to be 2. And then we can go ahead and use the Pythagorean theorem from here. 4 squared plus 2 squared equals c squared. 16 plus 4 equals c squared. 20 equals c squared. Square root of both sides, and then if you simplify your radical, 20 is equal to 4 times 5. Square root of 4 is 2, so that's going to be 2 times the square root of 5. All right. So we have that, and we can put this right here, and that is our lateral height. That is going to be our L. So using that right there will get us that lateral height for your triangle. All right, so we now have pretty much everything we need. I'll go ahead and establish that for each of these rectangles, we can go ahead and say that our base, we'll say, is 4, and then our height is 20. All right, so now we have everything that we could possibly need to plug in. P is 16. L is 2 square root of 5. Then divide by 2. Add 16. And we'll add 4 times 4 times 20. All right. Then we can cancel these 2's, and we just have 16 square root of 5. And that's going to be 16 plus 4 times 4 is 16, and then 16 times 20 should be 320. And then we could call this 336 plus 16 square root of 5, or we can plug that into our calculator and get a decimal approximation of 371.8. And we can say that this is square meters, since this is surface area and our units are in meters. So these are the two acceptable forms for our answer that you may see problems like this with. All right, go ahead and have all that down, and I will see you the next time.